Hi, I'm Miss Morrison. Today we're going to solve an area problem. We're going to do this pictorially, but I'm also going to show you this with a mathematical computation so that you can see the pictorial representation and the mathematical computation, and you'll be able to see how they are both the same. So, let me read you the problem first. Mrs. Smith is planting a rose garden. The rose garden is 5 yards long and 2 2/3 yards wide. In square yards, what is the total area of Mrs. Smith's rose garden? So here I have graph paper, and this is what I'm going to illustrate the solution for you pictorially. So how are we going to start with this? Well, just to go back over what we know in this problem, we are told that we have an area that is going to be 5 yards by 2 2/3 yards. So where are we going to start? We have this grid and we have these numbers, and we're wondering, what do we do? Well, we have the 5 yards and we have 2 2/3 yards. If we look at this, we can see that we're dealing with thirds in our representation, and with our length being 5 yards and our width being 2 2/3 yards, if we convert our yards into thirds, both with our length and our width, that will allow us then to work with thirds. And why do we select thirds? Because we're actually given thirds in one of our dimensions. So 5 yards will equal how many thirds? So we're looking for an equivalency, and 5 times 3 is 15, so 15 thirds equals 5 yards. Two 2/3 yards, we already have this in thirds. 2 times 3 is 6 plus 2 is 8. So that's 8 thirds yards. So we have 15 thirds for our length, and we have 8 thirds for our width. So now we can start looking at our grid and knowing that if we have a length of 15 thirds and we have a width of 8 thirds, we can start laying out our grid. We could also go into our mathematical computation at this point, but let's work on our grid first. If we're working with thirds, then each of our units could be a third. 1/3, 1/3, 1/3, so that each of 3 of the thirds would equal 1 yard. And we would continue that so this would be 1 yard, 2 yards, 3 yards. Let's go ahead and continue that all the way across so that we can see for our length, this would be 1 yard, 2 yards, 3 yards, 4 yards. And this would give us 1 more yard for 5 yards. So 1 yard, 2 yards, 3 yards, 4 yards, 5 yards. We could do the same thing for our width, and let me go ahead and erase that. We're working with 2 2/3, so here would be 1 yard. This would be 1 yard. But for our width, we have 2 2/3. So this part, this would be 1/3 and 1/3, which would represent 2/3. So we have 1/3, 1 yard plus 1 yard plus 2/3 here, where here we have 1 yard plus 1 yard plus 1 yard plus 1 yard, and that's actually going to equal 5 yards. So that would represent our length. This would represent our width. 1 yard plus 1 yard plus 2 yards. And again, each of these all the way across, each of these units, individual grid units, would equal 1/3. So we could actually count each of these and see how many of these we have. But I think what I want to do is to color them in so that you can see them a little more clearly. So if we were to color these, and I'm going to break these up so that you can see them actually in different colors, because each of these is going to represent its own individual yard. Okay. We can keep coloring this until we get then we can come over here, bring this in, bring that in, bring that in, bring that in, and actually bring this in down here. Bring in another color here. And we'll put that one up there. And the reason that I'm doing this is to illustrate for you how each of these is actually representing a yard. So I'm stopping where I get over here to the end of my 5 yards, and I'm stopping over here when I end with my 2/3 of a yard. And one more. Okay, so we've colored it in. And at this point, we can see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 thirds. 15 thirds coming across. And those 15 thirds represent the 5 yards. And then 1, 2, 3, 4, 5, 6, 7, 8 thirds represents 2 2/3. Remember we said 2 2/3, an equivalent fraction for 2 2/3, because 3 times 2 is 6 plus 2 is 8. 2 2/3 equals 8 thirds. Just like 5 equals 15 thirds. Okay, so what is this telling us, and how is this helping us? Well, what it's asking us is, let's go back to what the question is asking us. The question is asking us how many square yards Mrs. Smith's rose garden is. So our mathematical computation is actually 5 yards times 2 2/3 yards. So if we were going to multiply that out, we would have 5 over 1, because we're dealing in yards, times 2 2/3, which this is a mixed number. If we convert that into an improper fraction, 3 times 2 is 6 plus 2 is 8, 8/3, that equals, which is our numerator times our numerator, over our denominator times our denominator. So that is 40 over 3. And if we count these, we have 15 across and 8 down. And if we multiply that out, 8 times 5 is 40. That's 120 units that we have here. 120 units. This is dealing in yards. And if we simplify this, 3 will go into 40 13 times with 1 left over. And so our area is 13 1/3 yards, which is equivalent to 120 units on this grid. So here, if we count our thirds, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. And this is the 40 that is represented here. Our 40 groups of thirds. Our 40 groups of thirds. And that is the 5 yards multiplied by our 2 2/3 yards to get our 40 groups of 3, which is also represented if we're talking units, because we have 120 individual units. We have 120 thirds in here, individual units, and that's represented by 15 times 8. But don't get mixed up by that. This is units, this is yards. So these are groups of 3. Each of these groups of 3 is what is represented in this 40 thirds, this fraction of 40 thirds. Because each of these, and I could go through and group each of those individually, but I've colored them differently for you so that you could see. Each of these represents a group of 3, and we have 40 groups of 3 in this pictorial model. So we have pictorially demonstrated that Mrs. Smith has 40 thirds, or when we simplify that, 13 1/3 yards, square yards, don't forget that, square yards as the area of her rose garden. Not units. The question asked us, how many square yards is her area? So we are multiplying yards times yards, and that equals square yards. All right, that is the problem for tonight. What we do want to do always is to go back and reread the question. Mrs. Smith is planting a rose garden. The rose garden is 5 yards long, 1, 2, 3, 4, 5, and 2 2/3 yards wide, 1, 2, 2/3 yards wide. In square yards, what is the total area of Mrs. Smith's rose garden. One other thing I didn't mention was the formula for area. Area equals length times width. Formula for area. And that is what we did right here. The length is 5 yards. The width is 2 2/3 yards. So this is the equation that we actually solved right here. Area equals 5 yards times 2 2/3 yards. And we solved that for 40 thirds, which simplifies to 13 1/3 yards. And pictorially, we demonstrated it as well. Okay, that's it for this evening.